All right, so here's our questions from, well, yesterday, I guess, / the other day here. It says here, for the following graph, calculate the slope from 0 to 20 seconds, from 20 to 40, and 40 to 60. So we're going to have 3 different parts to this here. And again, we have 3 different lines here. So from there to there, okay? And let's just worry about this part first here. So from there to there. So again, if you're looking for the slope, I'm going to do it on here, and I'm probably going to erase it. So if you need to copy anything down, make sure you're doing that, I guess, as I go here, because, like I said, I'm going to probably erase this as soon as possible here as well. So 0 to, let's see, 0 to 20 there. So if I want to calculate the slope here for this section, okay, I would, again, talk about the change in y over the change in x, basically, or if you want to, let's maybe do points on this one. Why don't we do points? That'd be 20 and 10 here for that point, and of course this is 0, 0. So I'm going to do what? 10 minus 0. That would be measured in meters. Make sure you use units. 20 minus 0 seconds. Okay? Because your time's in seconds here. So that would be this minus this. Okay? The change in the x is there, basically. So rise over run, you can also do it that way if you want. The rise is 10, the run is 20. So 10 over 20 is 0.5. We probably should have, what do we need here? We probably need to have 2 significant digits. I think we need to actually have this, okay, 2 significant digits. So that first section should be 0.50 meters per second. So basically a half a meter a second. Okay, that's not very fast, of course. Half a meter a second. That'd be a kind of leisurely pace, as I'm sure you're aware if you think about a meter stick. Okay, now we're going to go to the next section, and of course, if you guys paid attention yesterday a little bit here, we talked a little bit about yesterday, from here to here, slope of a horizontal line. And what is the slope of a horizontal line before I even do the calculation here? Somebody, quickly. Answer me, please. Anthony, what's the slope of a horizontal line?
I don't know.
Nikki, what's the slope of a horizontal line? That's right. So we have the 20 and 10 here. Okay, is that point there? 40 and 10 is there. Those are 10s there. I know it's really messy there, but 10 minus 10 basically meters here, that'd be 0 meters. And how long? It takes, what, 40 minus 20 seconds, or basically 20 seconds. So we're going 0 meters per second. And of course that makes sense because look, we're stuck at 10 here. We're not going anywhere. We're stuck there for this period of time. So 0 meters per second would be that part there. Okay? 0 meters per second. Slope of a horizontal line is 0, always. Okay? It just kind of depends on now. If the slope is 0, what is the graph though? I mean, it still depends on what the graph units are. Okay? We're going to get rid of some of this so it's not too messy here. And then the last part here, we're going from 40 to 60 here, of course. Up here is the point 60 and what is it, 40, I guess? Okay? And this is what? 40 and, so x and y, 10. Okay? And again, if we're talking about the slope here, okay, rise over run if you want. What do we got? 40 minus 10 meters. Okay? So 40 minus 10 is the change in the y. 40 minus 10. And the x here is, 60 minus 40. And that's in seconds. So what do you get? 30 meters over 20 seconds, or 1.5 meters per second. Okay? And that would be the answer to this part here. Okay? Is that good, everybody? Questions, anyone? Because this will be our next quiz here in the next coming few days here, probably sometime. Okay? Any questions on that? Does that make sense? It says basically when is the speed the fastest? The fastest speed is from 40 to 60 seconds. And remember, this is the steepest slope as well. It is the most upright slope, okay? Therefore, it is the fastest slope. So 40 to 60 seconds is what you want to put there. When is the object not moving? It is not moving, as we know, in this section right here. So it is not moving right here from what, 20 to 40 seconds. It is not moving. Describe the overall motion of the object, okay? This question here is going to be kind of a common theme here as we go through these different types of graphs, and we're going to look at another one here today, but that is a pretty common theme. They want to know what's happening, or give me a scenario here that would fit this data. Okay, well, from 0 to 20, you could say that the object is traveling at what, 0.50 meters per second. So that's the first part I would talk about. From 0 to 20 seconds, the object, because I don't know what this is, it doesn't have a title here, 0 to 20, the object is going at a rate of 0.50 meters per second. From 20 to 40, the object is at rest. Okay, so that's something that's a word that you want to be using here is at rest. The object is at rest. Okay, and then from 40 to 60, it is going at a rate of 1.5 meters per second, or you could say a speed of 1.5 meters per second. That would be okay as well. Okay, is there any questions on that, anyone? Ask. Okay. All right. Well, we're going to move on to this one here now. Okay, so I'm just going to scooch that up here. Now, create a distance versus time graph. Calculate the slope of the graph. What does the slope represent? So, a little bit of practice here. Distance. Okay. This is going to be measured in meters. I know that because of this chart right here. If you haven't done this, make sure you do this. This is going to be good practice for you. That is the time in seconds, and I know that because of this right here. Now, what else should I put on here? Well, I probably should put a title, yes? And I'm going to call it the distance versus time. Now, I don't know what this is of, okay? So does it, because it doesn't say here. So I'm just going to put distance versus time graph. That's all I can do, okay? Just give me 1 second here. I'm going to stop this first. So, yeah. Now, again, we need to kind of, we talked about how to make graphs. 0 to 30 is my range here. This is the x-axis, of course, 0 to 30. So I have a range of 30 minus 0, or basically 30. How many squares do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? So I'm going to have 20 squares, and if I divide those two numbers, it's 1.5. Now, okay, and that's okay, all right? So here's the deal. Here's where this gets a little tricky here. Should I go 1.5, 3, 4.5, 6, etc.? So should I go up by 1.5s here? Would that be a good decision, yes or no? What do you think? Somebody. Could you do that? Yes or no? Quickly. Come on. You're wasting my recording time. Hurry up. Can you go up by 1.5? Would that work?
No, really, since we've only even like distribution, so I could go up by 2 instead of like 1.5.
Okay. Okay, I'm not exactly sure what you're saying, but okay. I could go up by 1.5. Like I could make this 1.5 and 3, and I would get up to what? This would actually be 30 here, yes? So that would work. The problem is, am I going to hit any of these numbers on the x-axis? Well, you're going to hit 15, because 1.5 does go into 15 evenly. You're probably going to hit 30, because that'll go into 1.5 will go into 30. But all those other numbers, and I don't know if you understand what I'm saying right now, but all those other numbers are not going to be on one of these lines here. Now, that could happen, and that if it happens, it happens. But is there a better way to do this so that we do get like 5, 10, 15, 20, and still spread this graph out? And the answer is, well, probably, okay? So look, this would be 1.5. This is 3. This third one would be 4.5, okay? What I'm going to do instead, and I don't know if this is going to make sense to you or not, but what I'm going to do is, like, I don't need to label every square here. Like, I don't have to go 1.5, 3, 4.5, 6, 7.5, 9, etc., etc. I don't have to do that. I have to come up with a scale that's appropriate and kind of uses up all this x-axis. So probably what I'm going to do is, instead of every third one, like, 1.5, 3, 4.5, so that third one is 4.5, here's what I'm going to do. I'm going to go to the third one here. 1, 2, 3. I'm going to call this one 5. This is going to be my 0 here. Okay? And I'm going to go another 3. 1, 2, 3. This is going to be my 10. There's my 15. There's my 20. There's my 25. And there's my 30. So this part of the graph, yeah, I mean, I'm going to be kind of done after this. But, okay, that's pretty good still. I'm using most of the graph, okay? And that's what we talked about before. As long as we're using most of the graph, that's the important part, okay? That's the important part. So that's probably what I would do with this one here, okay? Now, again, if I went every third, if I went every one was 1.5, this would be 3, 4.5. So what I did was I just increased this one to 5, basically. And I looked at, and the reason I'm doing that is because I looked at these numbers here, and look, these are all equal 5s, right? 5, 10, 15, 20, 25, 30. So this is going to work out well. And you might say, well, why don't I just use, can I just put the 5 and the 10 and the 15, 20? No, because you're not going to use the entire graph or a good portion of it, okay? So hopefully that kind of makes sense to you, how we're still spreading it out, but we're picking some logical numbers for that, okay? And that's okay. Actually, what is this division right here? I don't even know, to be honest. I guess it would be, what, 5 divided by 3, because that's how many divisions we have there. So whatever that is, I guess that's what each one of those is. I don't really care because I don't have to worry about it, okay? Now, going up the y-axis, we have 0 to 60, okay? And I'm pretty sure, somebody can correct me if I'm wrong, but each square is going to be, what, 3 in this case. I got 20 squares again going up, and each square will be 3, okay? So a range of 60 divided by 23. So each time is going to be 3. Now, here's where we have to just be a little bit careful, okay? And I look at this set of data, I'm like, oh yeah, 0, 9, 18, 27. Oh, that one, no. But most of those numbers are actually divisible by 3, and that's a good thing. That's going to work out pretty well. Even if they're not divisible by 3, we kind of have to go with 3 in this case, because we kind of need to have some equal values. So here's what I'm going to do. I'm not going to label every square. I'm going to label every square that kind of makes sense. Like, look, there's 9, 18, etc., etc. So I'm going to go up by 9s, but I'm going to go up every, this would be 3, 6. I'm going to label this one 9. This would be 12, 15, 18. Okay, do you see what I'm doing? I'm kind of just labeling every third one. This would be 21, 24, 27. I'll label it. 30, 33, 36. I'll label it. 39, 42, 45. 48, 51. No, wait. I screwed that up, didn't I? Did I? 48, 51, 54. Do I have enough squares here? Or did I screw my 1, 2, 3, 4, 5, 6? Oh, no, I did. What did I do here? What did I mess up? Did I mess up something? 1, 2, 3. 1, 2, 3. 1, 2. No, wait. 1, 2, 1, 2, 1, 2. Is this? What's going on here? Somebody help me here. What did I screw up? 9, 18, 27, 54. This would be 54, 57. Oh yeah, that's that's right, I think, isn't it? Is that right? Yeah, I think is that right? Somebody help me out here.
Yes.
Yeah.
Okay. Okay, sorry. I guess, yeah, anyway, that's kind of what I'm going to label. Now, you label every square there? Sure, you could, but you'd have to write pretty small, obviously, for that to happen. Okay? We're going to go ahead and plot some points here. So I'm just going to grab 0, 0 here. Okay, what do we got? 5 and 9. Okay, perfect. That's right there. Okay, 10 and 18. Perfect. That's right on the corner here. Like it so far. 10 and 18, 15 and 27. 15 and 27 right there. Okay, 20 and 38. Now, here's where things are not going to quite match up, right? 20 and 38. So that right here would be 20 and 39, and I want to be slightly below that. So 20 and 39, or sorry, 20 and 38, I should say. So probably about there, roughly, give or take a bit. Just a little bit below that corner. 25 and 49, so that'll be 48 there. So just a little bit above, right about there. Oops, maybe there, kind of thing. And what do we got? 30 and 60, of course, which will be right on the corner here. Okay, so there you go. There's your there's your plotted points. They want you to calculate the slope. Well, how are you going to calculate the slope of this graph? Well, you're going to have to, obviously, you're going to have to kind of draw a line of best fit. Okay, now, again, here's the problem. What is our line of best fit going to look like for this? Let's find out. Sorry, I need, no, I need this one. I need this one. Here's the one I need. Okay, so I kind of usually try to start out with the first and last point here. Let's see here. Okay, and I guess you have to ask yourself, is that a good line of best fit? What do you guys think? Is that a pretty good line of best fit or not? What do you think? I'm not going to say yes or no. You tell me. What do you think? Sabrina, what do you think?
It looks all right to me.
Okay. Cassia, what do you think?
I think it's pretty good.
Okay. Nobody wants to disagree, eh? Hugo, what do you think?
I think it's too high.
Yeah, possibly. Okay. And the only reason I would say I would agree with Hugo here is that, we kind of look at these points here, okay, like this one here, and this one here. They all seem, and even this one actually, those all kind of seem to be kind of below the line, don't they? There's really only, 3 points that are on the line, I guess, and we have 4 points that are kind of off the line, okay? So I think this might be a little bit too high here. We might have to kind of scooch this down a bit, okay? So maybe you want to kind of do this, okay? And then just bring this one down here a little bit like this, okay? What do you think of that? How's that? Let's see. Well, I think, no, let's take a look. Above, so this one's above, let me go back to here maybe. How do I get out of here? Oh, there we go. Nope, that's not it. Okay, well anyway, I'd say the first point's a little bit above. This one's kind of on now, right here. I can't seem to draw it for some reason now. Okay. Let's see.